For today's investigation, we're going to do a qualitative analysis on series circuits using light bulbs and the CPO circuit board. First, let's start out and discuss a little bit about what a parallel circuit is. So far, you've done series circuits, where we may have a battery or power supply, and we go into a resistor and another resistor and come back. If we want to draw these resistors as light bulbs, we can just put a circle around them, and there we go. The main thing with this circuit is that the current that comes out of the battery or power supply has only one place to go. So whatever leaves the battery comes back to the battery at the same rate. So there's never any electricity escaping the circuit at all. A parallel circuit is a little different. In a parallel circuit, again, we have maybe some kind of power supply or battery. This time, our current travels through one path, and at some point there's an additional path that it might be able to travel through. Again, if they're light bulbs, they look just like that. So the behavior of this circuit is considerably different than the behavior of the simple series circuit. So let's start with looking at some parallel circuits. Here we just have kind of a schematic of what's going on. So if we look at this circuit, we see that we have 5 amps flowing this way. Well, if 2.5 amps comes out down this branch, 5 amps has to leave the whole thing. So in other words, so if we have 5 amps and 2.5 comes this way, then we got to get 2.5 traveling through there. All right, similar to this one. Well, if we have 2 amps here, 1.5 amps there, well, we got to come back. 2 amps has to come back to the battery. So that's got to be a 2 amps. Then if this is 1.5, then this is going to be 0.5 amps. So that's how we go through and do these pre-lab questions. So complete these questions before moving on to the further steps. As I mentioned before, we're going to do a qualitative analysis. So in other words, we're just going to be looking at the brightness of the bulbs and determining which bulb or which configuration has more power and more current. So to start with, let's recall when we did series lab. All right, we looked at the brightness of a bulb in series. So there's the brightness of one bulb. And then, if you recall, when we put the 2 bulbs together in series, they became quite a bit dimmer. That's the type of observations we're looking for. Not something that's really, really subtle, but if there's big differences, you'll see them, or big changes, you'll see them. All right? And so, again, if we look at 1 in series, 2 in series. Significant difference in brightness. So that's the differences that you'll be looking for in the parallel circuit. You may or may not see differences like this, but you can use those observations to come up with conclusions based on what you see. To set up the parallel circuits, you're going to have a board like this. All right, put 2 batteries in here. Make sure they're both headed in the same direction. In other words, I got the positive here and the positive here, so the current's going to flow this way around. All right, well, here's our first bulb that we're going to have. All right, then to make it in parallel, instead of putting this bulb between the battery and the other bulb, we're going to just set this one right here. then your task is to figure out how to get the electricity to go through this loop as well. And then when we do 3 bulbs in parallel, set this one right here. Again, your task will be to get the electricity to split into 3 branches and then come back to the battery. All right, so there's today's lab.